Flag register. Flag register is another part of 8086 microprocessor. Under the flag register, there are 9 basic components, which are carry flag, parity flag, auxiliary carry flag, zero flag, Sine flag, trap flag, interrupt enable, direction flag, and overflow flag. So 9 flags are there on 86 microprocessor. So this flag register categorized into 2 basic parts, which are status flag register and control flag register. So under the status flag register, carry flag, parity flag, auxiliary flag, zero flag, Sine flag, and overflow flag is categorized under the status flag. These status flag are carry flag, parity flag, auxiliary flag, zero flag, Sine flag, and overflow flag have taken or we calculate their contents on ALU or arithmetic and logic execution. So the remaining 3 parts, which are direction flag, interrupt enable flag, and trap flag, is the control flag. Let's see what are the basic concept, or how can we get the content or the value of static flag during the execution of the program with ALU. So carry flag means when an addition instruction is executed, if there is a carry on most significant bits, on the most significant bit, when an addition or subtraction or two's complement instruction is executed with ALU or arithmetic and logic unit operation on binary, if there is a carry on most significant bit. This flag also serves as the borrow flag on subtraction. For instance, when we see in a simple example, 1 0 0 1 0 1 1 0. So for instance, if this is an addition, ALU or arithmetic logic operation of addition, so to get the value of carry flag is equals to 1 when there is a carry on the most significant bit. Carry flag is equals to 0 if there is no a carry on the most significant bit. So let us add these 2 operations. 1 plus 0, on binary operation there is a 1, 0 plus 1, there is a 1, 0 plus 1, there is a 1, 1 plus 1, 1 plus 0, there is a 1. So there is no on the most significant bit. These are the least significant bit, these are the most significant bit. So carry flag is equals to 1 when there is a carry on the most significant bit. Carry flag is equals to 0 if there is no the carry on the most significant bit. These are the basic concept of a carry flag. The other part is a parity flag. Parity flag is to set 1. The parity flag is set 1 if the result of the byte operation or lower byte of the word operation contain even number of ones. Underline it. If the result contains even number of ones, parity flag or PF is equals to 1. If the result that contains odd number of ones, when we count the number of ones and it becomes odd, the parity flag it becomes a 0. Let's see on this example. To get the parity flag, PF is equals to 1 when number of ones from the result when we count it is equals to even. Parity flag is equals to 0 when we count the result number of ones or total number of ones from the result is equals to odd, the party flag it becomes a 0, right? So let's add this one again. This is 1, this is 1, this is 1, this is 1. So these are the result. These are the result. So the results that contain even number of ones, the party flag is equals to 1. If the result that contains odd number of ones, the party flag is equal to 0. Let's count the number of ones. 1, 2, 3, 4. So 4 is even number. So if the number of ones is even, party flag is equals to 1. So our party flag result it becomes 1. So party flag is calculated seems like for this one. The other part is auxiliary flag. Auxiliary flag. This bit is set if there is a carry from the lower nibble to higher nibble, either 3 digit or 4 digits. If there is a carry from one nibble in a sense 4 bits, right? So this bit is set if there is a carry from lower nibble to higher nibble, or D3 bit to D4. So let's see with an example. Let's add this one. For instance, this is a one nibble, this is another nibble, alright? We add all in together with the binary operation, but these are one nibble and this one is the one nibble. Carry flag is 1 if there is a carry on the most significant bit or on here, but auxiliary flag or AF it becomes 1 if a carry from one nibble to another nibble, right? If there is a carry from one nibble to another nibble. So let's add this one. There is a 1, 0, 1, 1 plus 1, 0, carry with 1. So this carry comes from this nibble to this nibble. So 1, then add this one, 1 plus 1, there is a 0, remained 1, 1 plus 1, there is a 1, 0 plus 1, there is a 1, 1 plus 1, there is a 1. So as you have seen on here, these are one nibble, these are the one nibble. So when we add this one and this one, there is a carry. This carry is taken from this nibble to this nibble. So auxiliary flag, it becomes 1. So calculate the auxiliary flag by this way. But for instance, if I give the value for this one, let's add this one. 1 plus 1, 1, 1 plus 0, 1, 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, this one, it becomes 1. So there is no carry from this nibble to on this nibble. So if there is no a carry from one nibble to another nibble, auxiliary flag, it becomes a 0. These are the concept of auxiliary flag. The other part is, the fourth part of status flag register, which are 0 flag or ZD. This flag sets the result of operation A lose zeros. If the result it becomes a 0, 0 flag it becomes 1. 0 flag is equals to 0 when the result is 0. For instance, this is not 0, this is not a 0. For instance, this one is 1, 2, 4, 8. This one 1, 2, 4, 8. So 4 plus 8, which are 12, 12 plus 2, which are 1, 4. These are 1, 4. This one is 8 plus 4, which are 12, 12 plus 1, which are 1, 3. So the result is this one, and this one is different from 0. So 0 flag, it becomes 1. It becomes 1 when the result is equals to 0. 0 flag, it becomes 0 when the result is not 0. So on this instruction, the value of 0 flag, 0 flag is equals to 0 because the result is not 0 or the result is different from 0. The fifth part of status flag register, which are Sine flag or SF, after the execution of arithmetic, operation, the most significant bit of the result is 1, then Sine flag is set 1. Otherwise, the same flag it becomes 0. For instance, on this instruction, when we add this operation 1 0 1 1, then 1 0 1 1. So this is the least significant bit. These are the most significant bit. So if the most significant bit value is equals to 1, sign flag is equals to 1. If the most significant bit is equals to 0, sign flag becomes 0. So the most significant bit on this operation is equals to 1. So the value of sign flag is equals to 1. So sign flag works on this way. The last part of status flag register, which are overflow flag or OF. So is it if the result out of the range? So overflow flag is equals to 1. Overflow flag is equals to 1 when the result is out of the range. For instance, the range of this bit is 8 bit. So if there is a carry on here and it becomes 9 digit, it's out of the range. So if the result is out of the range, the overflow flag is equals to 1. If it is not out of the range, or if the result is based on its range, the overflow flag becomes 0. For instance, on this instruction, there is an 8 digit for all operands, and also the result also 8 digits. So overflow flag is equals to 0 because it's not out of the range. The result is inside of the range. For instance, let me change this value and let me show this one. 0 plus 1, there is a 1. 1 plus 1, there is a 0, and there is a carry of 1. So because this represents as in 9 digits, so during all this time, overflow flag is equals to 1 because we have only 8 digits, but there is a carry or another digits which are 1. So overflow flag is seems like for this one. Exercise. Give the content of the flag register after the execution of the following condition. After the execution of the following condition, or after the operation of this condition, give the content of the flag register. For instance, on microprocessor, we have 80, 86, we have 9 flag register. From those 9 flag register categorized with control and also status. This control we cannot interrupt or we didn't calculate its result. For instance, a direction flag, interrupt flag, and trap flag. It considered as direction flag, interrupt flag, and trap flag. It categorized under the control flags, right? It categorized under the control flags. On the status flag, on the status flag register, there are six flag registers are there. Overflow flag, carry flag, auxiliary flag, sign flag, zero flag, and parity flag. So the instruction says that give them the content, give the content of the flag register. Under the flag register, directly this question asks for us what is the value of this status flag register result. Overflow flag, carry flag, auxiliary flag, sign flag, zero flag, and party flag. So let's calculate the result before we set the value of these 6 registers. So the value is given 0 1 1 0 0 1 0 1 1 1 0 1 0 0 0 1 0 0 1 0 0 0 1 1 0 1 0 1 1001. These are the given value. These are the given value with addition operation. So let's add this one. 1 plus 1 0, carry with 1. 1 plus 0, there is a 1. 0. 1 plus 0 plus 1, there is a 1. Then 1 plus 1 0, there is a carry. 1 plus 0, there is a 1. 1 plus 1, there is 0, carry 1. 1 plus 1, there is 0, carry 1. Carry 1. So this carry is come from this neighbor to this neighbor. There is a carry 1, right? So let's add this one. Let's add this one. 1 plus 1, 1 plus 1, which are 1 0. Then plus 1, which are 1 1. So 1 carry with 1. Then 1 plus 0, 1. 1 plus 1, 0, carry 1. Then 1 plus 1, 0, carry 1. 1 plus 0, which are 1. Then let's add this one. 0, 1 plus 1, 0, carry 1. 1 plus 1, 0, carry 1. 1 plus 0, 1. These are the result. These are the result. These are the result. So these are the result. Then the content of flag register. The first one is, for instance, carry flag, auxiliary flag, sine flag, parity flag, zero flag, and overflow flag. So the value based on this result, or the value based on this operation, we must be set it. For instance, carry flag, if there is a carry on the most significant bit, there is a less significant bit, this one is the most significant bit. If there is a carry on here, carry flag it becomes 1. If there is no carry flag it becomes 0. So on the most significant bit there is no carry, so carry flag is equal to 0. Then the second one is auxiliary flag. Auxiliary flag means that if there is a carry from one neighbor to another neighbor. For instance, there is a carry from this neighbor to this neighbor. When we add this value, there is a carry, and this carry is taken to these neighbors. So auxiliary flag it becomes 1 because there is a carry from one neighbor to another neighbor. Sine flag it becomes 1 if the most significant bit is equals to 1. Sine flag it becomes a 0 if the most significant bit becomes 0. So our most significant becomes value is 1. So if the most significant bit is equals to 1, sine flag is equals to 1. So our sine flag is equals to 1. Parity flag says that if the number of ones from the result it becomes even, the parity flag is equals to 1. If the number of ones from the result odd, the parity flag is equals to 0. So let's count the number of ones from the result. 1, 2, 3, 4, 5, 6. So number of ones is equals to 6. 6 is even. So parity flag, if the number of ones even, the parity flag is equals to 1. So our parity flag is equals to 1. Overflow flag. Overflow flag is if the result is out of the range. If the result is out of the range. When we add this value or when we calculate this arithmetic operation, we have got 6 digits. Our input also 6 digits, so our result is not out of the range. So if it's not out of the range, the overflow flag it becomes 0. If out of the range, the overflow flag becomes 1. So it is not out of the range, or the result is inside of the range, so or between the range, so overflow flag it becomes 0. The other part is there's zero flag. Zero flag. The other part is 0 flag. The value of 0 flag it becomes 1. If the result is 0, the value of 0 flag it becomes 1 if the result is 0. If the result is different from 0, uh, the value of 0 flag it becomes 0. So our result, for instance, on here there is 9, on here there is 2, on here there is 9, just like that one. This one is 10. So our result is different from 0. If the result is not 0, 0 flag becomes 0. These are the content of flag register after over operation of this instruction.